Hey guys, this is a quick video here for the practice problems. We will do two separate videos. The first is on the simple regression forecast model. We will use two methods for this demonstration. The first is doing an equation on the graph, and the second is by creating a regression table. So this is the data that we have, the consumer price index data, and this is the y variable, and the years are the x variable in time. So the first attempt we want to do is to create a regression model on graph. As you will see, this is the solution. And let me show you the solution and then walk you through the steps. In this solution, we use graph only to solve and create the model. And how we go about that is we insert a graph and we select um, Before we do that, we need to highlight the Y variable, which is the CPI that we want to predict the CPI or forecast the CPI for years 2013 and 2014 using last 10 years or worth of data. And so we highlight the CPI as a response variable, and we insert a chart, and that's what we have here. So we created a chart, but if you compare these charts, you'll find a little difference. This one scaled from 150 to 240. This one from 0 to 250, which is okay. We still can use it just to show you that there is a difference that we can work with and adjust it according to the graph that is showing. The answer here is um, we can format the axes, and we can set that up from 150 to 240, and that will show us. Now we are seeing the same trend of the same graph. As a matter of fact, we can even scale it to the same position that they look exactly identical. And then we highlight the data and right click and go down to add a trend line, and we select a linear trend line, and therefore now we have a trend line that looks exactly the same. And then the third step is to left click on that trend line and then right click on the trend line and click to format, and then all you need to do is scroll all the way down and say display equation and display r square. And once you do that, you get the exact same equation here, which you can use to predict the future. For example, if you compensate here the variables of x, which is time intervals, the number of the time interval, and the r square, you can get a solution for what it looks like in 2013 or 2014. Now, if you want to use regression analysis using a regression table, what we will do is we will insert sort of a column and then change the years into time intervals. So we call this time, and we change the years as sequence time intervals. So we'll put that time interval 1, time interval 2, and then we drag these to create the time sequences. And then we go to data tab, data analysis, select regression from the menu, and then we're going to set CPI as our Y variable, and then we will set time as our X variables. We highlight labels since we have labels here, and then we request a new worksheet, and we hit OK, and that will give us a regression table. Now, to compare the results of the regression table to the results of the graph that we created here, let me copy this graph here and then paste it, and then take it here on the side. Oops. Okay. So now you will see that here is the equation. I can make it a little bigger. The 180.5 is the intercept that the table gave us, exact same number. The time, the x now is the t, which is time. The coefficient for the time, or the x variable, is 4.988, which is the same as we have obtained from the graph equation. The r squared is 9.8, and the r squared here is the same. And as you know, the r squared is the effectiveness of the model, or the accuracy of the model, which tells you that 98% of the time will explain the variation in CPI. This is what that means. This is what the R square means. The percentage of explanation of variation in the response value. So now these are the two methods for simple linear regression utilization to forecast behavior. And all you need to do in the equation is basically use the time sequence. For example, if we go back here, this time sequence will be 11, this time sequence will be 12, and that's what you use in the equation here, is put 4.98 times 11 plus 180, and that will give you the 235, and then you can use 489 times 12 plus 180, and that will give you the 240 as well. And we will be very certain that these are mostly a very accurate forecast, because the R square is so high, close to 1 or 100%. So that's it for this example, and we'll create another video for the other example where we look into seasonal variation and forecast. Thank you.